Hey, boys and girls, welcome back. It's Mr. Irwin. Today, I am very excited to introduce you to the wonderful world of proportions. So grab a notebook, grab a couple sheets of paper, um, and follow along. Here we go. First off, we're going to start with the definition of a proportion. You see it on your screen. It is an equation stating that two ratios are equal. And I have an example of a proportion down below. In this proportion, or this equation, I have two ratios, 1 to 2 and 2 to 4. I know that both of these ratios mean the same thing because I could take the ratio 2 to 4 and reduce it down to 1 to 2, or I could take the ratio 1 to 2 and use a common multiple to convert it to 2 to 4. So for example, both of these ratios mean the same thing because I can go from 1 to 2 by multiplying by 2. And I could repeat the same process down here. To go from 2 to 4 is multiplication by 2. And because I'm using the same factor, I know that both these ratios mean the exact same thing. We can also work backwards between these two ratios. I can go from the 2 to 4 to 1 to 2. Going from 2 to 1 is division by 2. 2 divided by 2 is 1. And same thing down here with the 4. 4 divided by 2 is 2. And so because I divided both parts of these ratios by the same value, I know that they are equivalent. And when you have two ratios that equal the exact same value, we call those ratios a proportion. Our first example gives us two ratios, and we're testing to see if the ratios 3 to 4 and 9 to 12 are proportional. I'm going to show you two ways you can test proportionality. You use the one that works best for you. So before we begin, we want to take both of these ratios and rewrite them in fraction form. So I'm going to take the ratio 3 to 4 and the ratio 9 to 12, and I'm going to write them in fraction form. Now, our task to prove proportionality, or to prove that both of these ratios are equal to each other, is to find a common factor or multiple that could link these two ratios together. So if you look at our top numbers, a 3 and a 9, can you think of a number that I could multiply 3 by to get to 9? Well, 3 times 3 is 9. Now, if these ratios are proportional, that means to go from 4 to 12, I should be multiplying by the exact same value. And yes, 4 times 3 is 12. So because I used the same number to multiply both numbers in my ratio to convert it to the other ratio, I know that these ratios are proportional. They are equal. They mean the same thing. Yes, these ratios form a proportion. I want to take the exact same ratios, 3 to 4 and 9 to 12, and I want to show you a second way that we can test proportionality. Another way to test proportionality is using cross products, meaning I'm going to multiply the numbers in the ratios that are diagonal from each other. So starting with this 3, diagonal from the 3 is a 12. So I'm actually going to work out what 3 times 12 is. And 3 times 12 works out to 36. I'm going to repeat the same process with my other diagonal, the 4 and the 9. So I have 4 times 9. 4 times 9 is 36. Now look at this. I got the same value for both cross products. When the cross products are equal, that means my ratios are equal, and that means, yes, they do form a proportion. If you would cross multiply or find your cross products and you would get two different values at the end, that would prove that your ratios are not proportional. They are not equivalent. They do not equal the same value. All right, second example, grab a sheet of paper if you haven't yet, copy down these two ratios, 12 to 27 and 4 to 9, and let's test proportionality together. Step one is to write these ratios in fraction form. They are already set up for us, but I'm going to rewrite them down in our workspace. So I have 12 to 27, and I have 4 to 9. All right, first method, look for a common factor or multiple that links these two together. Can you think of a way to get from 12 to 4? Well, 12 divided by 3 is 4. Let's test that down here with the 27. What's 27 divided by 3? 27 divided by 3 is 9. So because I divided both numbers in the initial ratio by the same value to get the new ratio, that tells me that, yes, these ratios are equivalent. Yes, they form a proportion. If you like using cross products, that's another method you can test out. 12 to 27 and 4 to 9. Cross products, we multiply our diagonals. I like to start with the top number in my first ratio, 12, and go to its diagonal. In this case, it's a 9. So we're working out what 12 times 9 is. 12 times 9 is 108. And then we're going the other direction for 27 times 4. 27 times 4, guess what? It is 108. Our cross products are equivalent. That means our ratios are equivalent and proves that, yes, these two ratios form a proportion. All right, one more example. We have the ratios 7 to 9 and 20 to 26. Copy those two ratios down and let's test proportionality. So my first ratio, 7 to 9, and then I have 20 to 26. So starting with my 7 and getting to 20, I can't think off the top of my head quickly a number I could multiply by 7 to get 20, because the number we would use to multiply is a decimal value. It's probably going to be pretty difficult to find. Same thing down here with the 9 to 26. 9 is not a common factor of 26, so there is not a whole number we can multiply 9 by to get 26. So probably the easiest strategy to use to test proportionality here is to test the cross products. So starting with my 7, I'm going to work out 7 times 26. And if you need to, grab a calculator, no worries. I'm going to use one here, 7 times 26, and we get a product of 182. Now I want to do my other diagonal. I have 9 times 20, so I'm working out 9 times 20 on the side. Again, if you need to, punch that into a calculator. 9 times 20 is 180. Look at our cross products. Did we get the same value? 182 and 180. Those two values are not equal. So that proves that the ratios 7 to 9 and 20 to 26 are not proportional. No, they are not equal. No, they do not form a proportion. All right, on your screen, I have 3 sets of ratios for you to test proportionality. Copy them down. Use one of the strategies we discussed in the previous examples to determine which ratios form a proportion and which ones do not. Once you have them copied down, pause the video, work it out on your own. When you're finished, hit play, come back, and check to see how you did. All right, hopefully you gave yourself enough time to complete all 3 of these problems. Let's test them out together. Number 1, 5 to 6 and 15 to 18. I see a common multiple I can use right out the gate because I know that 5 times 3 is 15. And down below, 6 times 3 is also 18. So because I use the same number to multiply both numbers in my ratio, number 1 is a yes. Those ratios are proportional. They are equivalent. Number 2, 5 to 13 and 13 to 33. I don't see a common factor or multiple I can use right away. So I'm going to use cross products on this method, starting with 5 and 33. 5 times 33 is 165. And then my other diagonal, 13 times 13 is 169. Those values are not equal, so no, those ratios are not proportional. And then finally, 16 to 28 and 32 to 56. I don't see a whole number that I could multiply or divide either of those by to get the new ratio. So I'm going to go ahead and do cross products. 16 and 56, grab your calculator if you need to. 16 times 56, I got 896. And then my other direction, 32 times 28, result was 896. Cross products are equal. That means the ratios are equal. And yes, they form a proportion. All right, I want to show one more thing we're going to do with proportions today. We have our first example on the board. C to 5 equals 6 to 15. So in proportions, sometimes one of the values will be unknown. It will be missing, and it will be represented by a variable. And it will be our task to determine what value of that variable will make this proportion true. So we are essentially solving for the value of C. I'm going to show you two methods to try this out. So copy down on your sheet of paper, C to 5 equals 6 to 15, follow along, and then determine what strategy works best for you. Strategy number one, just like testing proportionality, we are looking for a common factor or multiple that links these two ratios together. So I'm looking at the bottom here. I know 5 to 15. I know that 5 times 3 is 15, but if I'm trying to find the unknown value in this C, I need to work back to this first ratio. So I'm actually going to work from 15 to 5. To go from 15 to 5, I would divide by 3, because 15 divided by 3 is 5. I already know that these ratios are proportional because they're equal. There's an equal sign in between them. So that means if I am dividing the bottom numbers by 3, I got to do the same thing to the top. And in this case, we're working 6 divided by 3. 6 divided by 3 is 2. So I know this proportion is true when C equals 2. That's our solution. So that's method number one. Method number two, let me copy down the proportion again. I have C to 5 equals 6 to 15. If you can't find a common factor or multiple like we did in our first example, you can use cross products to solve proportions. I always like to start with my variable in the proportion, and I'm going to multiply that diagonal. And I have C and 15. And because we're doing cross products, we are multiplying those values. So C times 15, if you remember from our unit on algebra, C times 15 works out to 15C. Now I'm going to drop my equal sign, and that will allow me to perform cross multiplication with my other diagonal, in this case a 5 and a 6. I know that 5 times 6 is 30. Once you've performed your cross products, you should get an equation that you're able to solve. If you remember from our previous unit, to solve an equation, our goal is to isolate the variable C. We did that by building a wall on our equal sign, determining in this case that C is being multiplied by 15. So to solve for C, I want to do the inverse. The opposite of multiplying is to divide by 15. And to keep our equation equivalent, we're going to do the same thing to both sides. So I am dividing both sides of my equation by 15. The multiplicative inverse will leave me with just C over here on the left side of the equation. I drop my equal sign, and now I'm performing the calculation on the right. 30 divided by 15. That works out to 2. So I get to solution C equals 2, which matches what we figured in our first method. Again, use the method that works best for you. Next example, 5 to 32 equals 10 to P. Take a moment, copy it down. Let's work through this together. All right, so I'm trying to find the value of P that makes this proportion true. On top, I notice a 5 being changed to a 10. So that should be a pretty easy connection because I know that 5 times 2 is 10. So I'm going to repeat the process down below with the 32. 32 times 2 is 64. So I know that this proportion is true when P equals 64. The other method you could use, cross products, 5 to 32 equals 10 to P. I'm going to start with my variable P and multiply its cross product with 5. P times 5 is 5P. Drop our equal sign, and then our other diagonal is 32 times 10, which is 320. Now that we have an equation, we can solve for P. P is being multiplied by 5. The inverse is to divide by 5. Perform the same thing to the other side of the equation. We are left with P equal to 320 divided by 5 is 64. So no matter which method you choose, you should get the same solution. All right, one more example. Take a look at the numbers in these ratios. We have 3.6 to K equals 9 to 27.45. Now, just because we have numbers written in decimal form, it's probably going to be pretty difficult to find a common factor or multiple that will allow us to just find the value of K in one move. So our best option in this case is to just cross multiply. Starting with our K, we're going to work K times 9. K times 9 is 9K. Bring over our equal sign, and then our other diagonal is 3.6 times 27.45. This seems like a good reason to pull out our friendly calculator. 3.6 times 27.45. I got a result of 98.82. Let's go ahead and solve for k. Splitting my equation into two sides, I notice that the 9 is touching k. That means k is being multiplied by 9. To solve then, we would want to do the opposite. The opposite of multiplying by 9 is to divide by 9. Whatever I do to one side of the equation, we are doing the same thing to the other side. That will leave me with k equal to, and then on my calculator, I'm doing 98.82 divided by 9, and that gave me a solution of 10.98. The proportion is true when k equals 10.98. All right, boys and girls, on your screen, you should see three proportions with three variables that you need to find the solutions for. So go ahead, copy down the proportions, pause the video, and solve for each of the missing variables. When you are done, resume playing the video to check your work to see how you did. Okay, let's go over these and check your work. So number one, I'm going to do cross products. X times 12 is 12x equal to 6 times 8 is 48. Now to solve for x, I'm going to divide both sides of my equation by 12. And I am left with x equal to 48 divided by 12 is 4. Your solution is x equals 4. Number two, cross products again. 4 times z is 4z. Drop my equal sign. 3 times 28, 84. Let's go ahead and solve for z by dividing both sides of the equation by 4. That leaves me with z equal to 84 divided by 4. Double checking my work to make sure I don't write a wrong number up here. I get a solution z equals 21. And finally, solving for k. Diagonally from the k is a 27. K times 27 is 27k equal to my other diagonal, 12 times 45. Double checking my calculation on a calculator gives me 540. And now we're solving for k by dividing both sides of our equation by 27. Leaves me with the solution k equals 540 divided by 27. Solution k equals 20. Boys and girls, please don't forget to complete the independent practice assignment on proportions. Take a picture of your work and upload that file for submission. I'll see you guys next time.